Hello, welcome back to my second part of the RobotDog project. In this video, I'm going to build the electronics for the RobotDog. I will also describe each component's purpose.
Is the ESP32. This is a microprocessor which is used as a brain for the robot. This processor will handle the inputs, the outputs, the calculations, and the communication between other devices. Now, the communication for this device is made easy because this board has integrated Wi-Fi and Bluetooth, so we do not need additional modules. The chip also has a dual-core processor running at 240 megahertz, which makes calculations very fast. That way, there is a lower delay on input and output signals and commands sent to the robot. Now, this chip will be mounted on a PCB, a printed circuit board, but I will not mount it directly because then I have to solder the chip directly to these solder points, and then it's not interchangeable. If this chip might break, I want to replace it with another one, so I want to be able to change chip whenever I want. So that's why I will use some female pin headers. These will be soldered to the board, and that way the chip can be replaced if necessary. Additionally, another row of female pin headers will be added so that other devices can interact with the ESP. So if a device would need, for example, a ground, then you can plug it into this one, which is attached to the ground. That allows us to have multiple devices attached to, for example, the ground or several input pins. Part of the brain is the PCA9685, which is a 12-bit PWM driver. This board will be used to send PWM signals to the servo motors and drive them to desired positions. The servos will be attached to the first row of pins, which are designated as PWM. The voltage plus line and the ground line will not be used because the current that the servos need is much higher than this board can handle. So the servos will be attached directly to the power source. This board is also going to be soldered to a PCB, again, not directly, but also by using pin headers. I've chosen this PCB because I can use these two lanes for power and ground, and I can use these islands of 3 to mount this one vertically and have 3 pins available for the PWM, the voltage plus, and the ground, exactly as the connectors for the servos are labeled. The component for the brain part of the dog is this MPU 6500. This is a gyroscope and an accelerometer. This will be used to determine the pitch and the roll of the robot. So for example, if the robot is leaning towards the left, the chip will notice that it's rotating, and I can send a signal to the 2 legs on this side to stabilize the robot so it's straight again. And the same goes for the pitch. I'll probably mount this one on the same board as the ESP, and I can make the connections between the pin headers and the board directly between the different islands. So for the power delivery to the system, I'm using a big 2-cell LiPo. This one in particular is rated for 6,500 milliamperes hour and has a 70 C discharge, so it can discharge enough current to power all the servos without them having issues. So the LiPo is a 2-cell, which means it's 7.4 volts. That's enough for the motors, but it's too much for the control part of the brains. So that's why DC-DC buck converters are used. So I have two units, one big one and one small one. So the power from the LiPo battery goes in here. It goes to this big DC-DC converter, which will have an output for the servo motors. This one is mainly used to regulate the voltage to the motors so it remains stable. And I will also solder the on-off button to this one so that the power to the servos can be cut off by an external switch. The battery is also attached to a smaller buck converter. This one converts the 7.4 voltage to 5 voltage, and this 5 voltage, or this 5 volts will be powering the brain electronics like the ESP and the PCA and MPU. So the last part of the power grid is the security or the measurement of the power. And for that I will have a display in the back of the robot, which will show the voltage that's outputted from the DC-DC converter, so on the servo side. It will also show the current that's being used. It will also calculate its power usage in watts. For that I have a shunt resistor, which will be mounted between the load and the DC input, as shown on this diagram. That way we can measure all the different voltages and currents that go through the system.
had the whole world at our feet, watching seasons change. Our roads were lined with adventure, mountains in the way couldn't keep us from the sea. Here we stand, open arms. This is home where we are, ever strong in the world that we made. I still hear you in the breeze, see your shadows in the trees, holding on, memories never change.
In the end, I'm pretty happy with how this turned out. Parts fit perfectly inside the robot's body with some extra space for the connectors. The battery is mounted on the other side of this plate and is connected to the red and black connectors on the top right. The buck converters convert the battery voltage to a steady 7 volts for the servos and 5 volts for the ESP32. The ESP powers the PCA9865 PWM driver, which in turn controls the servos. There is a lot more going on after connecting all the servos to the custom PCB attached to the PWM driver. The keen eye might also notice the addition of the MPU to the ESP32 proto board. I soldered this one on off camera. The PCA is connected to the ESP, but the connections are a bit tight on the left side of the robot. With all the mechanical parts and now the electronic parts finished, we can finally move on to programming the robot. The first part of this programming will happen in the next video. So stay tuned. Thanks for watching. If there are any questions, feel free to ask them in the comment section below. I'll be happy to help. See you later.